everyone, welcome back to the channel. As always, I'm the big guy and this is the Big Guy Fix. And in today's video we have a Xbox 360 Elite that was donated to me by my nephew, who says there is no power and it doesn't switch on. So let's give it a go. So we'll plug this into the power board up here and we'll see. Have a look. Doesn't switch on. Alright, so what I think the issue could be is this power supply here. So the Xbox 360 power supplies and Xbox power supplies in general, when they had them external, were very notoriously faulty. They would break down a lot, and I know when you went to go to trade them in, they wouldn't take the power supply because they're that faulty. So I think our issue is with this power supply. So what I'm going to do is I'm going to pull the power supply apart and we'll test around in there, see if it's getting voltage on this end, see if the voltage is being converted on the other end, and then we'll see where we can find the fault. Okay, so the power supply, I've unplugged it from the power, and to get into these things, it's got 4 screws. Usually they're under these feet, but I've already just pulled the feet off, and it looks like it takes a size 5 star bit. So we'll open it up. Okay, and we finally got it out. There you go. All 4 screws are out. Let's just give this a squeeze and then open. And there we go. Okay, and here's the power supply. Alright. So like I said, I've disconnected it from the battery, so from the power, not battery. And we want to see, I'm going to plug it back into the power now, and I'm going to see if we do get voltage at the terminals. You got to be very careful with power supplies, because even though it's switched off, these capacitors here, they can hold some charge. Actually, this one here I should say. What we can do is just to double check. I've made a light with some leads in it, and we can use this to discharge the capacitor. All we need to do is put this across the terminals, and the capacitor should turn on, and then it will dissipate. And once this dies, that means the capacitor has been discharged. So let's give it a go. We'll see. That. Looks like it's dead. There's no voltage in that capacitor. Okay, I'm going to pull the board out and then we'll go from there. Okay, so I've pulled this apart, and when pulling it apart, I flipped it over and look what I found. I don't know if you guys can see this. Bring it up to the camera. Can you see that? There's a whole big black scorch mark here. Looks like something's burnt out. And if you look even closer, it looks like it's burnt the tracks. See the tracks between here and here, it's gone, and this track here between here and here is gone. So I'm not too sure how repairable this power supply is. I will keep having a look at it and see if I can repair it, but it looks like there's a lot of things that have blown. I think it might be this MOSFET here that's connected there, as well as maybe these capacitors might have blown as well. So it's not going to be a quick fix, but I'll keep messing around with it and I'll let you know how I go. Let you guys know how I go. Okay, so I think I figured out the problem. We have looks like a faulty MOSFET here. I think it's a MOSFET. It could be a diode bank, but I'm pretty sure it would be a MOSFET. I'll look it up on Google and see what it says. But what was happening is this MOSFET here, testing it in diode mode, we should, let me sorry, spin this around so you guys can see. I'm pretty sure you can see like that. Okay, so if we go across, this should be the common or the base, and what you should read is something about 0.6 or actually 0.8 maybe. We're getting stuff at 0.4 and 1 at 0.8. So I think these has actually blown, and once this is in circuit, he puts a short circuit here. So because I've desoldered it already, so you might not see it properly, but there's a capacitor just here, and if you can see how it shows the resistance. I should probably solder it back in so you can hear the beat, but it shows that it's putting a short across this capacitor. But I've actually desoldered it, and once we pull it out of the circuit, and then we go again and we test against that capacitor. Actually, sorry, this is in diode mode. That's probably why you're getting something. Where is it? That's resistance. Oh, there you go. There's the buzz. So this continuity test. Actually, make sure testing it properly, because it turned me out into a liar. I think I was okay. Or maybe this capacitor is blown as well. Or maybe we'll change that one too. Let's just double check that. So where is that capacitor? That's this ceramic capacitor right there. Let's test that again. Make sure we're on it. Okay. So we probably will change that capacitor as well. Looks like it blew it and blew the capacitor too. There's also these tracks that we need to repair, which shouldn't be too hard to repair. With a little bit of maybe just some wire, or we'll see if we can fill it up with some what's it called, some solder. But yeah, so I'll have to order that part. I don't have any, and we'll see. This is a diode here. Let's just check that in diode mode. This diode here, 0.08. The other way around. See, again, this diode might be gone too. So I think this has put a lot of shorts on there, because it seems like it's created a lot of heat. I don't know if you can see this here. Oh wait, let me see if I can get it in the light. There's a big scorch mark, that was sitting like that on there. So for it to have died like that, it must have created a big short. So I'll order in the parts that we need, and they may take about a week or so to come in from eBay, and we'll continue the video on from then. Bye for now. Okay, so now it's the next day, and upon doing a bit of research about these parts that I pulled out of the power supply, I found out a few things. So this part right here, this is not a MOSFET, as I was saying. Remember, I was saying it's a diode bank. Well, it kind of is. It's actually a bridge rectifier. What a bridge rectifier job is, or its purpose, is to convert AC into DC. And this basically is just a bank of diodes that are connected in a kind of rectangle shape, and these two pins on the outside, that's your positive and your negative, and the two internal ones are your AC. And so to test to see if this is working, we test in diode mode. So I've got the multimeter in diode mode, and so we'll take, let me just double check where the positive and the negative are. Can't really see. Okay, so we have positive pin here, so we can test between positive and one side of the AC. We should get nothing, which we do. Now if we swap our leads and test this way, we should get a voltage drop, 5.15, which is decent. You can get anything between, I'd say, 4 and anything up to 8, so that's good. So if we test between these two, again, we should get nothing, and we swap our pins, we should still get nothing, which is good. Then now we test between the last two. Again, we've got our negative on our negative and our positive on this pin. We should get nothing. Then if we swap it over, we should again get another voltage drop, 5.2, which is good. On some of these rectifiers, you can test between the last two pins. You should get the voltage drop between the two. So this way we get nothing. Swap it. There you go. So that's about right. So that's the two. So that's the voltage drop. The addition of both voltage drops, which is roughly about right. There's a bit of tolerance, maybe 10% minus or 10% plus. So turns out this bridge rectifier is actually working. We actually don't need a new part. Put that aside. Now this thing here that I thought was a ceramic capacitor is actually a thermistor. What a thermistor is a resistor that works on heat. So it should have a very, very high resistance when in room temperature. So it should be something around maybe the 10 or 11 meg ohm, and that resistance drops as it gets warmer. So to test this, if this is still working, we'll test it. So I'm going to test it with continuity. So it shouldn't have continuity because the resistance is so high. Sorry about that background, that's the dryer. So this shouldn't have continuity because it should have a very high resistance in room temperature. So if we test across these two terminals, we really shouldn't get a buzz. That should be reading something in the meg ohm, and we've got 14 ohms. So this is the thing that's faulty. This is the one that's burnt out. So let's test that again in actual, just in resistance mode. So this is just resistance. Test across, so we should see something around in the meg ohms, but what do we get? We get 12 ohms. So this is faulty, this is what we need. I've looked online to find these things, and they're pretty easy to find, but with coronavirus, these things are going to take at least 2 or 3 weeks to come in. So I'll put that on order, and we'll get that. Also, I had another look at this, at our power supply, and if you guys can see right here, this spot right here, there's another diode, and I have a feeling that this diode isn't working. So if we flip it over and we find the diode pins, which are these two here, again, like I was saying before, when you test a diode, you should get a voltage in one direction and nothing in the other direction. That's what a diode does. It allows voltage one way and doesn't allow voltage back the other way. So if we test one way, we should get a voltage drop, 0.0, and I think that's a little bit high, or sorry, it's a little bit low. And if we swap them, again, we should get nothing this way. And swap them again. we get a voltage the other way as well. So I think this this diode here is busted as well. So what I'll do is I'll pull that out of circuit and I'll order one of those too. But I thought I would make this little quick addition to the video before I upload it, just to let you guys know that what I was saying earlier was a little bit wrong, and that's what our now new problem is. So this here, this is working. This is now a bridge rectifier. That's working. This is our faulty thermistor, so it's not a ceramic capacitor, it's actually a resistor that works on heat. This is the one we need to replace, and I'm pretty sure we're going to need to replace this diode right here. Okay. Well, that's all I wanted to add for the video. I will upload this as maybe a part 1, and we'll do a revisit once the parts come in. But other than that, I'll catch you guys in the next one. The next one's going to be a little bit different, so please stay tuned, and I hope you guys enjoy. No worries. Hello again, everyone. Okay, so it looks like this power supply is a power supply that just keeps on giving. So I was having another quick look at it, and I found some more scorch marks. I'm going to bring this up to the camera and make sure you guys can see. Let me tilt it. Let me see. I don't know if you guys can see in there, but it looks like we have a burnt MOSFET here, and a capacitor and some resistors. It's probably going to be easier for me to pull them out of circuit, and then I'll test them on camera and make sure you guys can see how they are faulty. Okay, so after pulling these components out of the power supply, turn this back on. Okay, this is what I found. Okay, so we have this here, which is it's a 3-pin diode, or almost a transistor. This was what was remaining of a ceramic capacitor, and we have these two burnt resistors. So as you can see, this fault has caused a lot of heat. So what I think has happened, the fault has occurred. So if you look at this, the power supply, we have, let's look at it this way. We have our 240 volt, so this is our mains. So this is where our mains power from the house or outlet comes in through here, through the transformer, and that rectifier here, that was here, is what chops it down and turns it into DC, which we get out on this end that goes into the Xbox. So what I think's happened is that thermistor's blown out, the one that was sitting up here, and that's, if you look back here, that is put a fault through, down, into the DC side, which has created these scorch marks here. This is where I've pulled out the 3-pin diode that was connected into here. The resistors were there, and that capacitor, that little short capacitor was right in there. I'm not too sure how fixable this power supply is. I'm pretty sure there's probably going to be other things wrong with it. But just for the sake of the video, I will order those parts in and try and fix it. You might even blow up on video, which might be a good video to watch. Okay. So just quickly, these let's just test these quickly, these resistors. I'm pretty sure you're probably going to get either an open circuit or maybe a really low resistance. Let's put this in, it's already in ohms. So with resistors as well, the good thing is I've got a whole bunch of resistors, but we can kind of tell, if you can see these marks, we can kind of read what value the resistor is going on those colored marks. But we'll test it here across the resistor. It looks like it's 47 ohms, but I think this is going to be bad, probably going to be bigger value. And how about this smaller one here, 15 ohms, and I also think this is going to be bad. Not 100% sure what the value is. I'm going to have to look at it properly and read it. But I've got a whole bunch of resistors here that we can swap out. And then back again with this 3-pin diode. I kind of think this diode is working, but we'll test it again and just check. So we'll put it in diode mode. That's diode mode there. So once again, like before, we'll take our positive into our middle pin. We'll test one way. We get nothing. Then we'll swap it over, test again. We get a voltage drop. And these are Schottky diodes, so the voltage drop's a little bit lower than usual. And then we'll go again. We'll go from our middle to our last pin. We'll get nothing. We'll swap it around. We get another voltage drop, which is about the same. So I think this is still pretty good. We can probably reuse this. And that capacitor can't even be tested. That thing is shattered. It's gone. And there's as well that diode that I pulled out. I kind of broke it, but turns out this was still pretty good as well. So I guess we'll test one way. We get no voltage drop. We test another way. I think actually this one might be bad because this voltage drop is very high. So you shouldn't get a voltage drop in that range. It should be at max around 0.8. And that's reading at 1.9, so I think that's pretty high. Okay, so I'll order up these parts, see what happens, see what comes in. I think this is going to be a two-part video. I will upload this section here just to show the fault finding, but it will be a while before I can update this. It's going to take at least, I'd say, 2 or 3 weeks to get the thermistor in and some capacitors, and I think this and this will be reused, and maybe the diode. So it'll be about 2 or 3 weeks to upload the next video. But as I was saying before, the next video will be something a little different. I hope you guys, please stay tuned. I hope you guys enjoy that. And before I leave, I want to say a big shout out to my nephew, Isa, for giving me this power supply. This has actually been a lot of fun, and hopefully I can unfix it and get it working. Other than that, please like and subscribe. If you guys are enjoying it, please show some love, like, subscribe, share, tell your friends that the big guy is here to fix your electronics. Anyway, bye for now. Catch you in the next one.